All right, tonight's homework is 36 through 88 even. Yes? Get out a sheet of paper. Are we ready to go? Does everyone have the calculators? All right, number 38. The directions on 38 say, determine two coterminal angles and measure one positive and one negative for each angle. Okay? Legitimately, you need to have your calculator up, and you are just going to take, and this is a negative angle. Is this negative angle bigger than the 360 though? Like, is it surpassed the 360? That means it's a double corkscrew angle. Do y'all understand that? One corkscrew is 360 degrees. If it's more than 360 degrees, it's a double corkscrew angle. If it's more than a double corkscrew angle, then the 720, then it's going to be a triple corkscrew. Do we all understand that? Okay? So what we're going to do is we're going to take negative 450, negative 445, and we're going to add 360 to it. So if we do that, we are going to get negative 445 plus 360 is going to give you negative 85. So negative 85 degrees is going to be your first angle. That's a negative angle. Now I have to get a positive angle yet, right? So how do I obtain a positive angle? That's still negative. So to obtain a positive angle, I'm going to take the negative 85 and I'm going to add another 360 to it. And when you do that, that's going to give you 275 degrees. You know how before I told you to add 360 and subtract 360? That only works if my angle is not a double or triple corkscrew angle. Does that make sense? Yes or no? Any questions on 38A? Okay, 38B, same exact thing. This is negative 740, so I'm going to add 360 to that. And again, this is more than a double corkscrew angle. So negative 740 plus 360 is going to give you negative 380. So there's my negative angle, right? But I have to do that again. And that's going to give me negative 20, but I already have a negative angle, right? Would that work for another negative angle? It would, okay? But I need to come and get a positive angle, so I have to add another 360 to that. And that's going to give me the 340. So now I have a positive and a negative coterminal angle. Do we all understand those problems, yes or no? Okay, next section, 45, rewrite each angle in radian measure. So how do I go from degree to radians? This is 315 degrees, so I need to multiply it by a value of 1, but it has to cancel out the degrees. So the degree symbol has to go down the bottom, and the pi symbol has to go on top. Do we all understand that? Yay or nay? So you're going to have 315 pi over 180. And if you literally type in your calculator 315 divided by 180, it's going to reduce it down to 7 pi over 4. There's your radian measure. Do we all understand that, yes or no? Visual or verbal, y'all are with me on that. Make sense? Part B. Same exact thing, that's 120 degrees. I need the degree symbol to cancel out, so that's why the 180 degrees is on the bottom. Pi is going to go on top. And again, that's going to be 120 pi over 180. The zeros cancel out. 12 over 18 is going to reduce down by 2 pi over 3. Yes? Do we understand how to do this section of your homework? May I change the slide? Next section is going to be 50. This one says rewrite each angle in degree measure. Do not use the calculator. Okay, I know you guys are going to use the calculator to reduce. I'm okay with that. All right, so this is going to be negative 4 pi. I need to reduce this, but I have to have my radian part cancel out. My radian part is going to be the pi, so the pi has to go on the bottom, and this is going to be 180 times 4. The pi's cancel out, and negative 4 times 180 is going to give you negative 720 degrees. Do we understand that, yes or no? Same exact thing for part B. This is a radian measure. I have to multiply by either 180 over pi or pi over 180. I need my radians to cancel out, so the pi goes on the bottom, the 180 goes on the top, those pi's cancel out, and 3 times 180 is going to give you 540 degrees. Do we understand that section of homework there? Any questions? You notice how I'm going by section of directions here? Okay, number 56. Number 56, the directions will say, convert the angle measure from degrees to radians. Round your answer to 3 decimal places. Okay, so I'm going to go ahead. I'm going to transfer over here to my calculator. Yep, probably not. So I'm going to go ahead. I'm going to close this. We're going to get a new document, calculator page. Now, when you go to your calculator, this is super duper important. Y'all with me? If you click on your battery, or if you go over and hover by your battery, literally if you hover on your battery's symbol, it tells you what mode your calculator is in. See, this said angle and then dash dash degrees. That means my calculator is in degree mode. Generally speaking, to do calculations, you want it to be in radian mode. So if you click on your battery symbol, and you go to document settings, where it says angle, you want that angle to be in radians. And then I'm going to click OK. Now, whenever I hover over my battery, now it says rad. So rad, radian mode. You with me? It says radian mode. Do we all understand that? Now, the directions in this says to go ahead and convert the angle measure from degrees to radians. So if I have negative 46.52, is that what it was? Okay, and that is in degrees. I simply need to multiply that by what? How do I convert a degree to a radian? Yep, I'm going to grab my pi symbol. I'm going to divide it by 180 degrees, and that is my decimal equivalent. And it says to round how many places? Round your answer to 3 decimal places. What would you have there? Negative 0.812. Do we all understand that? Yes or no? Are we good? Okay. So you're just multiplying this by that, and that's going to be negative 0.812. Okay, convert the angle measure from radians to degrees. So how am I going to do this? I'm going to multiply that by 180 over pi. Yes. So negative 4.2, the pi's would cancel out times 180, and that's going to give you negative 756. See how I didn't type in the pi's? I didn't type in the pi's because I knew the pi's would cancel out. Do we all understand that? Yes or no? Okay, next. Use the angle conversion capabilities of a graph utility to convert the angle measure to decimal degrees form. Round 3 decimal places. Currently is in DMS. What's DMS stand for? What's DMS stand for? Degrees, minutes, and seconds. Now, here's what I need your brain to understand. There are 60 minutes in 1 hour. There are 60 seconds in 1 minute. If your minutes are over 60, it's going to increase the degree by 1. Does everybody understand that? So if it would be 75 minutes, 75 minus 60 would be 15 minutes, yes? So you'd have 15 over 60, which reduces down to 1/4. Does everybody understand that? 15 minutes of an hour is a quarter of an hour, yes? Okay? So this right here, how many minutes is there? 30 minutes, right? We know that 30 minutes is what fraction of an hour? Right, so you already know that this is going to be 120, negative 124.5. You don't even have to use the calculator for that. But let's say it would have given you something that was not that. How would you use the calculator for that? You would go to the right of the 9, and in the right of the 9, I believe yours is going to be the second row. First column is the degrees, minutes, and seconds. So negative 124, arrow, 30, arrow, 0. And if you hit enter, it gives you that. What is that? What mode is my calculator in currently? It's in radian mode. So if I go ahead and multiply that by control division, and I do 180 arrow down pi, and hit enter, it's going to give me the negative 124.5. Do we all understand that, yes or no? Okay, so whenever I hit enter, whenever I was in the degree mode there, this degrees, minutes, and seconds, it gave me negative 2.172. That is how many radians it would be. What do I mean by radians? Radians is something I can measure. You with me? I can't put 180 degrees on my yardstick, can I? But 180 degrees is equal to what in radians? What is 180 degrees? Pi. What is the decimal equivalent of pi? Can I put 3.15 on a measuring tape? On a measuring stick, someplace on a number line? Can I put 3.14 on a number line? Yes, I can put 3.14 on a number line. So therefore, that is a measurement that you'd be using. Okay, that's exactly why I went ahead and converted this to radians for you, because we were in radian mode, and that's what it did. Okay, moving right along. Arc length. Arc length is S is equal to R times theta. Basically, what this is doing is it's giving us a circle. There's my circle. And if I go ahead and I cut this circle, this right here is your arc. So it's the piece of string that it wants to measure. That is S. This is S. So this part right here is the S. That is the arc length that wants to measure that. Theta is the measure in which that you are going to be cutting the angle. Theta must always be written as a lovely radian, because radians are what are on number lines. Do we all understand that? So your central angle that we're talking about, if they give it to you in degrees, you must convert it to a radian measurement so that you can actually find it on a number line if you would need to. Does everybody understand what I just said? If I say bake that at 350 degrees, I can't find that on a number line. So you have to convert that into a radian. Okay? Now, with that being said, the radius is still right here. That's your radius. We already know that. So how do I apply this formula? Well, very easy. Number 78 says the arc length is 31 inches and R is equal to 12 inches, your radius. So this is your R and this is going to be your S. So you simply write the formula. R is equal to, or S is equal to R times theta. And you plug and shut. You plug and shut. Find the angle in radians. So we are looking for theta. Bless you. So the arc length is S, that's 31. Your R was your radius, that's 12 inches. And theta we have to find. Bless you. So how do I find theta? How do I solve that? Divide by 12. So you can leave this in a fraction, making this 31 over 12 is equal to theta. Or you can convert that to a lovely decimal and put 31 divided by 12 decimal, and you're going to get, yes, you're going to get the 2.583. Bless you. Okay. Both of those answers would work. I think the back of the book is going to give you the fractional answer of 31 over 12. Do we all understand? Okay, the next one, same exact thing. This is number 82. It gives you R is 22 and S is 10. Go right for it. S is equal to R times theta. S is 10. R is 22. Find theta. Divide by 22. You're going to get 5 over 11 is equal to theta. And again, they'll accept the fraction answer. You don't have to convert it to a decimal. Any questions over that? And the last one. This is Yoder speaking. Okay, the last one here, same exact concept. S is equal to R times theta. But when you do this, what did I tell you theta must always be given it? Has to be in a radian. So my central angle is 3 pi over 4. Is that a radian or a degree? It is a radian. So S is equal to 12 times 3 pi over 4. That cancels out to give you 3, so S is equal to 9 pi, which is 28.27. And both of those would be acceptable. Okay, that is the rest of section 4.1. Any questions over tonight, what you're expected to do? I did a problem from every section of the directions, and that will conclude section 4.1. Monday, we are out of school due to Martin Luther King Day. Tuesday, we will go over the unit circle. Wednesday, we will do section 4.2. Thursday, we will do Math Excel, and Friday, you will have a unit circle quiz, and when you're done with your quiz, you'll finish your Math Excel. Any questions over what we're going to do for next week? We good? Okay, you guys have the rest of the period to get this done.